तो बच्चों, why I'm making this video? Let me again explain in the beginning. Because IIT asks a very good questions. बहुत अच्छा क्वेश्चन पूछती है IIT JEE. तो कुछ क्वेश्चंस को क्लास में जब हम डिस्कस करते हैं, जैसा मैंने क्लास में बताया था आपको, as I told you in the class, that sometimes I feel that you need some more explanation, better explanation, detailed explanation. So in order to provide you detailed explanation, exhaustive explanation, I thought why not to make videos for IIT JEE previous question. So I'm starting this series. Today I will be discussing isomerism, and especially I'll be focusing on conformational isomerism. Right. So whatever doubt you have sent to me on WhatsApp, just I have collected those doubt, and I'm going to discuss. Some previous year question might be left because you haven't sent, and those were very easy. So it basically consists of those questions. The discussion will consist of those questions which you have sent me on WhatsApp. So do keep on sending me your doubts on WhatsApp, and I'll make video and upload in YouTube. So today we are going to discuss previous year IIT JEE question of topic conformational isomerism. Right. So without wasting any time, let's start. The first question which I have taken, I'm going to share you. I'll keep on sharing from my laptop, and sometimes I'll discuss on the whiteboard, sometime on the blackboard. It's not black, it's also white. So in both whiteboard, on the digital whiteboard as well as the board which is behind me. Right, the first question is, this is the first question. Read first question, I'll enlarge it. It is the Newman projection of PQRS are shown below. Right? It is 2020 advanced question. Now, it says that advanced. Which of the following options represent identical molecules? So see, it is PQRS. All are Newman projection. Right? So, in order to decide whether they are identical or they are this, we should have eclipse form. Because the concept is eclipse form, we make 2D projection from eclipse form. हम eclipse form का 2D projection बनाते हैं, right? And the basic rule is make Y. Whenever you make a 2D projection, you should have 2 Y. One Y this and another Y this, right? And this you can say that handle. This is handle. This are handle of Y. What you will do, this is carbon number 1, this is carbon number 2. So what you have to keep in mind, let us say this is carbon number 1st, this is carbon number 2nd. So just put here, this is carbon number 1st, this is carbon number 2nd. Now if this is B and this is C, see B is on the right side, it will be on right side. C on left side, it will be on left side on carbon number 2. On carbon number 1, suppose it is P and Q. P on right side, so here P will be on right side. Q on left side, Q will be on left side. And what is here? Let's say here we have X and Y. Keep in mind these two X and Y, it will be at top and bottom. So at carbon number 2, the handle will be, this is the position of handle. These two are handle position. This is Y. Whenever you make Y, this is handle. I'm talking this as, I'm keep calling this as handle, and these are fork. Right? handle. So here you will have X. I'm sorry. Let's name it by different name so that there should not be any confusion. Let's call it one. Let's call it Z and W. So it is on carbon number 2. It would be W, and it is Z. So this is the rule. I'll summarize it again on the board so that it should be more clear to you, and then I'll again come back with the question. So look here, I'm doing the same thing on board. You know, आपको क्या ध्यान रखना है? And I'll be speaking in both languages, Hindi as well as English. So what you have to keep in mind, it should be in this form. One carbon here, it is eclipse form. If this is carbon number first, carbon number second, this is the handle of Y, this is W, this is Z. So what you have to do, this is carbon number 1, carbon number 2, handles are put at top and bottom. Here you have to put Z, here you have to put W. And see here, this is right side at carbon number 2. Let us say it is B, this is A. So here it would be B, it would be A. P, Q, right side is P, it would be P and Q. So what we are going to do, we are just going to take projection of all the options P, Q, R, S and just write their IPC name. If IPC name are same, they are identical. And accordingly, we can do take decision whatever option says, right? So this is the basic rule. I'll take one option on the board and show you how we draw it. So just look here, and the option I'll do on the digital board also. So first was this CS3, 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 C2H5. And here we have CS3, OH and CS3. So see what I'm going to do. The bad carbon consists of CS3, OH and CS3. I'm just going to put bad carbon like this. It is CS3, this, OH, this, and CS3, this. This is the bad carbon. Front carbon is this. This is the front carbon. This which starts the substituent of front carbon starts from here. It has C2H5, CS3, and this. Now rotate it so that it should be eclipse form. So just if I rotate by 60 degree, what will happen? CS3 will come here. C25 will go there, or just first I'll make the same structure. CS3 was there. I'm sorry, I messed up. CS3, C2H5, and H. So see here, it is CS3, C2H5, and H. Right? CS3, C2H5, CS3. I'm sorry, this is it. Now this is not the eclipse form. You have to bring into eclipse form, then only you can draw projection. If you don't rotate it, what you can think of, that this is right side, this is left side. At this moment, it is not making Y, it is inverted Y. This is handle, CS3 here. It is inverted Y. So if you have inverted Y, so what you can do, this is on right side. So when you take two dimension projection, you can keep on left side, you can exchange it. Either you can rotate it or you can exchange the position. So I'm going to do the same thing. This is carbon number first, this is carbon number 2. See here, first I'll do on carbon number 2. Carbon number 2 handle is, this is making Y. Look here, this is handle of Y, CS3. Right side CS3, it is CS3. Left side OH, so we have OH. This is carbon number 1. At carbon number 1, this is not Y, this is inverted Y. This has this position. So what you have to keep in mind, handle would be occupied by CS3. But we are going to exchange the position, which is the substituent which is on right position will make on left position. And the substituent which is on left position will be given right position. So this is on left, so we'll make on right. This is on right, we'll make on left. Now name it. So C2H5 should be written as CH2, CH3. Now find the longest chain consisting of the senior most functional group, which is OH. So this is the, so this will start from here, 1, 2. This is the chain, which is longest here. Now write application name 1, 2, 3, 4, and 5. So its name would substitute 3 CS3 are there. So its name would be 2, 3, 3 trimethyl pentane 2. Right? Now I'm going to do same exercise on the whiteboard. So hopefully you. Now I'm going to write the remaining 2 compound on whiteboard. Now look here. I'm going to write the name of this compound. This compound. This is the front carbon consisting of this. This is making inverted Y. Look here. It is not Y. Inverted Y. So what I'm going to do, this is the front carbon. So I'm going to put here like this. Back carbon I'll take by black color. H, CS3. See, back carbon, the back carbon, it is making Y position. So I'll just take all the substitution as it is. Okay. I'll just change the color, brown color. This is the back carbon. This is the back carbon substitution. H, S, and CS3. Okay. So I'm going to write CS3 here. H is on left side. Now what? This is the front carbon. For front carbon, what this is? Inverted. So I'm going to put here. This is handle of Y here. Carbon CS3. C, CS3, CS3, OH here. This was the handle of Y. And we have left side H. This is left and this is right. Since this is inverted Y, so right will be left here. So C2H5 will be here. So I am writing like this and H would be this side. Now identify the longest chain. Say this is the longest chain. Start from here. Longest chain should consist of the senior most functional group at the lowest position. Now write its name. This is carbon number 1, carbon number 2, 3, 4, 5. What is its name? Its name is, I'm writing the name here. It is at 2 position we have CS3, at 3 position we have ethyl. It is 3-ethyl, 2-methyl, pentane, 2-ol. This is the name of compound. Now look at the next option. Again, I'll repeat the basic thing. You have 2 possibility. If you have Y like this is the correct Y. This is handle. So it is on right side. It is on left side. It means when you take the projection, this group will occupy here. Left will be here and right will be here. Okay, but if you have inverted Y, this is the handle. Of course, it would be here, but left would be come to this side. This will come this side, right side here. And the right will come to this side, left side here. Right? So this is the rule basically which we are following. So I'm going to apply the same rule here. So hopefully by the end of this question, you will understand this rule. So look here, see here. Now tell me, the front carbon has 3 substituents. CS3, this bond, OH, and CS3. This is inverted Y. This is inverted Y like this. Here we have CS3. Here we have OH. We have CS3. The back carbon has, I change the color, H, C2H5 and C2H5. Means here we have C2H5. Here we have H. Here we have H. This is back carbon. This is normal Y. So we don't have to change. This is carbon number, let's say second. This is carbon number first. Let us draw the projection. Carbon number second. Carbon number first. At carbon number first, we have right side. Put right side here. This is on left side. Put on left side here. This is handle. Handle are put at top and bottom. So here you will have C2H5. At this position, handle would be CS3 here. CS3. So I'm going to write here CS3. It would be CS3 here. But since it is inverted Y, CS3 is on right side of this. Here it will be on left side. Now write the name by selecting the longest chain and keeping the functional group position lowest. So this would be the longest chain here. Name it. 1, 2, 3, and here basically it is 4 and 5. 2 carbon. Right? It is there are 2 substituent at 2 and 3. It is 2 methyl and 3 ethyl. So we have to write first 3 ethyl because E comes first in alphabetical order. 2 methyl, pentane, 2 ol. 3 ethyl, 2 methyl, pentane, 2 ol. Oh, P and Q and R is the same. This is R. So C option is correct. However, I'll write the name of S also for your benefit, right? Because I want you to understand the shortcut method. Since I'm explaining, it is taking much time. But if you now first identify the front carbon, it is inverted Y. Look here, I'm drawing this line, inverted Y. So what I'm going to do without wasting time, I'll write handle here, CS3, exchange the position. Oh, both sides we have H. That's all. Now the back side has 3 substitution. This, and this. OH. Handle it here. This is normal Y. Back side has normal Y. This is CH. We have 2 CS3 here. Right side. Left side C2H5. Let us make is this. Now longest chain. This will be longest chain. This position should be lowest. 1, 2, 3, 4, 5. If I write this way, 1, 2, 3, 4, 5. So V3 has ethyl. It is 3 ethyl, 2 methyl, pentane, 3 ol. There are some minor mistakes. These are gaps that are not there anyway, but this is the not matching with any of the answer. So we have already found this is the answer. So hopefully you understood the basic concept, how we write the this, right? So we'll be applying this. I'll show with the model also. I have made a model of conformational answer also, but when such question arises, then I use this model and show you it. The next question which I have taken for you is it's a 2008 question. The correct question about the compound given below R. So what is the correct option? Optically active, it's a more than one statements. So since it's a more than one correct answer, look here, statements, there could be more than one correct answer. So let us do this. Let's say it is carbon number 1 and this is carbon number 2. Carbon number 1 is normal Y. See, this is Y. So let us write the projection here. Handle is CS3. Left side is Cl. Right side is H. Fine. This is carbon number 1. Now this is carbon number 2. So now I'll focus on carbon number 2 only. I'll redraw it. I'll change the color. This is carbon number 2. Focus here. Carbon number 2 is, this is, although here I can write CSC like this. It is this is inverted Y. Inverted Y means, although handle will be CS3 here, but this is on left side. So this will come here right side. And this H is on right side, it will come on left side. Right? This is 2D production. Now, analyze the option and find out. If you look at the first option, the compound is optically active. So look at the symmetry. Can we divide the two equal part? No. If you try to divide, it's not same. So A is the correct answer. It lacks symmetry. It does not have point of symmetry either. If you draw line, but this CS3 are on the same side. If I draw a structure like this, it has, let us analyze one by one. It does not have plane of symmetry. We have just analyzed. It does not have plane of symmetry. When we divided into equal part, we could not. Now, if we try to find out point of symmetry, right side is Cl here, left side is H. Here Cl is on left side. Right? This is carbon number 1 and this is carbon number 2. Now, point of symmetry is the point. If you draw a line in two opposite direction, you'll meet the same substituent. So if you draw a point line like this, you'll meet CS3. And if you draw in opposite direction, you are going to get Cl. Fine. Then, but if you draw a line like this, you get CS3. If it had point of CS3, then you should have gotten CS3 here, but it's not there. Therefore, it lacks symmetry. Plane of symmetry as well as point of symmetry. You don't have any plane which is divided into two equal parts. You don't have any point from which, when you draw a line, see, point of symmetry means in a molecule, you have a point, generally a center. If from this point, if you draw a line in two opposite direction, this direction and its opposite direction, this direction, opposite, you will meet similar substituent. Then you will have point of symmetry. So it does not have a center of symmetry or point of symmetry. It does not have plane of symmetry. Axis of symmetry. What is axis of symmetry? Axis of symmetry means that, suppose, let's say a simple example, because we are discussing this, we are BCl3. If you rotate any molecule in one complete revolution, how many times you are going to get the same molecule? So you'll find that 3 times here. In one rotation, you are going to get the same molecule. Suppose we have fixed this, and if you rotate, when you rotate 120 degree, you will have similar shape. Again, if you rotate 120 degree, you have similar. 120 degree, similar shape. It means it has threefold symmetry. It's called, it has threefold symmetry. Now, if you look at this molecule, I'll draw this structure here. I'll draw the eclipse form here. CS3, this is carbon number 1. I'm drawing carbon number 1, Cl and H. This is carbon number 2. inverted. So I'll put here. So Cl will come on right side. Now, if you rotate this by any axis, this is the axis. If you rotate, this is on right side, keep in mind. And this is on left side. If you rotate by 180 degree, so this Cl, what will happen? See, this is carbon number 2, this is carbon number 1. I'll rotate and show you. You rotate it by 180 degree. So this C2 will come here, C1 will come here. I'll show you by model. Then it will be clear to you what I'm trying to say. Look here. I have a model. So in this model, let us assume this chlorine is black. This is chlorine. CS3 is red. And this is hydrogen. Chlorine is black. Or we have 3 different colors. Now we have another CS3 like this. Okay. So when you rotate it or focus like this is second carbon where black on right side. If I rotate by 180, it is, and the second black you can't see. It is towards me. But if I rotate by 180 degree, see, I'm holding at this hand. Black is in front of you. And I'm leaving this hand. The black of this, it is also black in color. It is away from you. This black is close to you. Now I'm rotating by 180. What will happen? The black pen, which is towards you, will be behind you. And the black pen, which is away from you, it will come in front of you. I'm rotating by 180. See, I'm holding this hand. This black pen went away from you, right? And this pen comes out. Now again, I'll rotate by 180. This pen, which is towards you, towards the viewer, will go behind you. And the pen, which is away from the viewer, will come in front of you. I'm rotating by 180. It means that by rotation of 180, you get same molecule. It has 2-fold axis of symmetry, right? So we have 2-fold axis of symmetry. Therefore, second option is correct here. It has 2 correct answers. A is the answer. And D is also the answer. Both are correct answers, right? Now we move on to next question. Okay, this is a very good question. A simple one also. So what is this question? Let us understand. In this question, we have the question is observed is summation of this. What does it mean? Understand, it's a very simple question, but since the mathematical expression is given, mu observed is summation of this, where mu I is the dipole moment of stable conformer. You know, stable conformers are anti and gauge. It means that if you write, because see here, CS2 ZZ. If you have this sort of thing, I'll draw the picture. Suppose you have Z here, H here, H here, right? This is the front carbon. And the back carbon is Z here, H here, H here. This is anti. And the second position structure could be like this. Z, H, 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 Z. This is gauge. Its dipole moment is mu anti, let's say mu A. Its dipole moment is mu gauge to mu A. Its mole fraction is XA. Its mole fraction is XB. See, look here. It was written mu is the development of a stable conformer and xi is mole fraction of that number. So this is the simple thing. Now it says that total observed means since in conformational isomer the molecules are keep on rotating, the total observed dipole moment would be summation of all dipole moment. So write stable isoform Newman projection. So this answer. So this is the part A. And if solution has this dipole moment, okay, this is the value. So fraction of this find mu Gauss. Anyway, it says that formula is this. Let us apply the formula. Mu observed means mu of solution, which is 1D given, 1D by summation of this means mu of NT, x of NT plus mu of Gauss. This. Now see here, it says that mole fraction of NT is this. You know, total mole fraction is always 1. Mole fraction of NT plus Gauss should be 1. Therefore, mole fraction of Gauss should be 1 minus mole fraction of NT, 1 minus 0.82, which is given 0.18. Right? Put here 1D equal to mu of NT 0.18 plus mu of Gauss. I'm sorry, NT form is 0.82. Put the wrong value. It is 0.8 to 0.18. Now NT will have zero dipole moment. Look here, the Z are on opposite side. So their dipole moment, this value would be 0. Mu NT would be 0 value, right? The dipole of this bond, CZ bond, will cancel this bond. They are opposite to 180 to each other. So this value is 0. So 1D is equal to 0 into 0.82. This is 0 plus mu into 0.18. Mu Gauss. Therefore, mu Gauss would be 1 upon 0.18. This is 0. So 1D, we have this term left. Answer would be 5.55D. This answer is 5.55 dB. Right? So this is the point here. Next is write more stable meso conformer of CH by D if Y is this and this. Now I'm going to draw this. Meso means CSD. We have here H, D. There are two H, D. Here we have Y. But one time you have to take Y equal to CS3. So let us make this Y as CS3. You know, the most stable form would be NT form. So this is carbon number 1, 2, CS3, H, D. And on this carbon, it would be CS3, D. This is the NT form. And OH, in case of OH, this is not the case because you know here we have hydrogen bond. So what we are going to do? First, we are going to draw this structure. CHD, the left side H, D, H, D. In place of Y, we have to put OH. OH, OH. Now, when you draw it, you will find, suppose we have drawn OH here, H here, H here. Second carbon will have OH at this position. At this position, it is in the best position to form hydrogen bond. The hydrogen bond. And the hydrogen bond is the reason of maximum stability. So Gauss form is the most stable conformation isomer in this case of when Y equal to OH, right? In this case, we have NT. In this case, Gauss isomer is most stable. Next question is, right. This is very good question. This is very good question. Let me slightly adjust the size. Now the question is visible. So first I can change the size. The question is, Fisher projection is there. I'll draw this structure. Fisher projection is there. And their P, Q, R is given. Read the question. The Fisher question D it shows is given. This compound is D, it shows. And it has 4 different isomers. P, Q, R, S here. P, Q, R, S. Column 1, choose the correct relationship P, Q, and R, S with the form. So it is diastereomer, anticicle, and enantiomer. Again, you have to take projection here. If you could take the projection correctly, you can easily answer it. What you have to focus on Y. And I'll repeat the same basic concept. If your Y, this is correct Y, this is handle. This is inverted Y. Handle is, this is handle. So the right side component will come to the left side, and left side, they will exchange the position. Right? This will be at top, this is bottom. Suppose I connect this. This is 1, this is 2. Keep in mind, when I connect it, 2 will come here, 1 will come here. But the substituent on this will be exchanged. Okay? Let us do this here. So I'm drawing this compound, only first compound. So let us see whether it is identical to this or not. Right? So I'll redraw it here for this is the compound. This is H and this is OH. Right? This is solid phase, this is gas phase. Here CHO, here we have OH. And S this side. Now the question is, how to draw it? So very simple. We can hold 1. This is 1 and this is 2. Right? So what we are going to do, we are going to rotate like this. We'll hold this, we'll fix it. Fix it. And we'll move this like this. Now I'm going to rotate. Look here. First will be at its own position. And the second carbon I'll bring here. First we'll have CHO here at the top. Left side will be OH. Right side will be H. Look here. Now on this carbon, I've rotated, I have just grabbed it here. This is the second carbon. OH here. Left side will have H and right side will have OH. See, this is now normal Y. This position is normal Y. This position is inverted Y. Take projection of this. Here, CH2OH we can write. It is normal Y, so it will occupy same position. But this is inverted Y. What we have to do? We have to exchange the position. H on right side, so right here on left side, OH on left side, so right on right. Now compare with this. It is identical. Right? So P is 2. P is identical. 2. So let us look at the option. There are 3 options where P is 2. A, C, and D. Right? Now let us look at Q. Although we can do permutation combination here so that we can eliminate, but I'll prefer to go a lengthy way. See here 2. So now I'm drawing Q. Again, I'll draw here structure and understand this. This line is on plane. When we don't write, this is on plane, CHO. This is basically CH2OH. And here we have H. And here we have OH. OH. This is carbon number 1. This is carbon number 2. I'll fix it. I'll rotate this carbon. Carbon number 2, I'll rotate here. Let us do this. I have fixed carbon number 1. It would be like this. This side we have H, OH, and I'm rotating it. Now here we'll have OH. This on, it will come to left side. It will come to right side. Now look at this is inverted Y. This is also inverted Y. Both are inverted Y. Right? How? Look here. Y inverted. This is Y inverted. It means that when we take projection, of course, we are going to write CHO and CH2OH here. This is the handle layer. This is the handle layer. But OH here on right side, so we are going to put on left side. H here on left side, so we are going to put on right side. Here OH are on left side, so we are going to put on right side. Now look, compare this. It's not identical. It's a diastereomer, right? So it is diastereomer. It's not mirror image or not identical. So diastereomer. So Q will be first. So Q first. First A, C, D were correct. And Q first, there are 2 places. Only this is matching. Therefore, C is correct. Right? So I'll just discuss something more because this is simple. What I'm doing is rotation. I'll just explain, not with this example. I'll take simple example. See, when we draw this line, single line, it is means in the plane. Let's say here you have CHO, here COH. These are in a plane. When we say it is dash line and this is solid line, so these are out of plane, right? So when we fix, suppose we fix it and we rotate it, it means that just we are holding, I'll show you with a model. I'll show with your model. Understand this, what I'm saying. Whenever you rotate, understand this model. First, let me tell you the color scheme. The 2 ball are carbon, right? ये जो 2 बॉल है ये कार्बन है. अब आप इसको देखिए, ये कार्बन है, इसमें रेड कलर plane are towards you and the black color plane will be away from you, and these are handle. It can rotate. That's why we have lots of conformation. Red color plane towards you. Now, when you rotate the molecule, always focus on the solid, not focus on dash, because solids is towards you. What I can do, I can hold this and rotate this. When I rotate this, see what is happening. The solid line, which is red here, which is towards you, it's going to which side? Tell me, left or right? It is going right to you. But if I rotate like this, if I hold this pen and rotate like this, they are going left to you, right? So what it means? It means that if I hold this, the handle will remain same. See, this is forming Y and handle is here blue color. Handle is blue color. So see, I'm rotating it. But when I rotate it, I'll hold this pen. Handle will be top, at the top. Just rotate it. The red color plane are facing the viewer. The black color plane are away from the viewer in the plane. Now rotate it. Say it is going to left side. But if I hold this pen, the red color plane will move to right side. So it means that you should always focus on solid ways. Then try to draw the 2D projection. Okay, I'll take one example. I'll take this compound and this compound. The difference is here, I have drawn two handle here. These are handle. This is solid, right? It is CHO, CH2OH. Let's say it is OH and H. OH and H. Now it is up to you whether you want to rotate about 1 or rotate about 2. Compound will remain same. All the answer will remain same, right? But what you should do, for time being, you leave this dash form. If you rotate around 1, it means you are rotating this. So what will happen here? CHO will be top, this will come and left, and on this carbon CH2OH, this OH will come on left. This is what I was saying. Of course, second group will go to that side, right side. And then you can take projection, whether it is normal Y or vertical Y, inverted Y. It is inverted Y. So when you take the projection, at top you will have CHO, at bottom you will have CH2OH. Since it is inverted Y, OH will go to right side, OH will go. This is the way we take 2D projection, right? You practice few times, you will find that you are very comfortable. It won't take much time. Now what you can do, we can rotate this one and keep this fixed. No problem. Always focus on this solid. This solid will go in opposite direction. It is towards you. As I told you, again focus here. This OH is towards you. This red color is towards you. If you rotate like this, it will go in this direction, in right direction. But if you rotate around this, it will go in left direction. Now, I'll fix this and just I'll rotate this. So what I'll do, I'll decide here. This I'll fix it. It will be CH2OH and it will be on right side OH. When I rotate it, this OH will also come to right side and CH2OH. Look here. Here we have H. Here we have. Now it is inverted Y. So when you take projection at this point, and then it would be CH2OH. But since it is inverted Y, OH will come to left side and H will go to right side. ये भी inverted Y है, तो क्या होगा? OH जो right side में वो left side में आ जाएगा. तो left side में ये इधर चला जाएगा. देखिए आपको same compound मिला, right? So this is the way we draw projection. तो आप इसको प्रैक्टिस कर लेंगे और बहुत सिंपल होता है. Y के टर्म में सोचना है. Always think in term of Y, whether it's inverted Y, normal Y. Normal Y, just draw it. Inverted Y, just extend it. Don't take much time. Next question is, this question is total number of stable conformer with non-zero dipole moment for the following compound is R. Total number of stable conformer, right? Stable conformer again with non-zero dipole moment. Dipole moment should be non-zero. So write all the conformer, all the three substituents are different here. So let us draw the Newman form, because Newman form gives a better view. This is carbon number 1, this is carbon number 2. First I'm viewing from this side. CS3 here. Left side Br. Now Cl, CS3, CS3. Always it is the Cl here. I'll draw from different color. Cl. Right side we have CS3, so right side I'll draw CS3. Left side Br, so left side I'll draw Br. Now we'll make anti, right? We are going to make 3 anti form. We'll keep the front one fixed, blue color fixed. This CS3, Br, Cl will keep fixed all the time. And one by one, we'll make all the stable isomer, means staggered form. It's not precisely staggered here. Now rotate one by one, right? First rotate this CS3. If I rotate to this degree, the Br will come here, Cl will come here, right? So CS3 here, Br here, and Cl here. The dipole moment of CS3 will cancel dipole moment of CS3, but the Br and Cl, they are not opposite. So dipole moment of Br will not be completely cancelled by Cr. और जो Br का Cl का completely cancel नहीं होगा, वो cancel हो जाएगा. इसका मतलब here dipole moment is not equal to 0. Again, this time, what we are going to do? We are going to, it is, let me again write as anti of CS3 here. Anti CS3 means CS3 are opposite to each other. CS3, CS3. Now in the next diagram, what we are going to do? We are going to bring Br opposite to each other. Okay. So let us rotate Br by 120. Yeah, bring here. Br by 120. Bring Br here. If you bring Br here, Cl will come here, CS3 will come here. Br will cancel each other, but see, in front of Cl we have CS3. Cl के सामने CS3 है, तो cancel नहीं करेगा. Again यहाँ पे dipole में 0 होगा. It is anti in term of Br. अब हम Cl का anti बनाते हैं, ठीक है? Let us make it is Cl here. So again rotate. It has become a dirty diagram. So I'll do it again. So CS3, Br, and Cl. Now I'm going to make anti in term of CS3. So first it was Cl here, CS3 here, and Br here. I'm going to rotate it, right? I'm going to bring Cl to this side. CS3, Br, Cl, this Cl to this side. If I rotate this, CS3 will come to this side and Br will come to this side. See, Cl, the dipole moment of Cl will be cancelled by dipole moment of Cl, but Br and CS3 will not cancel either. This structure is anti in term of Cl and Cl. ठीक है? तो क्या करना है आपको? बारी बारी से एक दूसरे का एंटी बनाना है. एक बार CS3 का एंटी CS3 बनाना है, एक बार Br का एंटी Br बनाना है, और एक बार Cl का एंटी Cl बनाना है. In all three cases, mu is not 0. Therefore, total number of stable with non-zero dipole moment, answer is 3. ठीक है? तो 3 तरह का एंटी हो सकता है, इसके अलावा और पॉसिबल नहीं है. This question is from 2004. C2 is rotated anti-clockwise. 120 C2 120. इसको रोटेट करा के यहाँ ले आए. ये हो गया CS3, ये आ गया, ये बन गया H. This is H now, and ये भी H रह गया, ये यहाँ आ गया. CS3 हो गया, तो ये गॉस फॉर्म. और आई ड्रॉ द नेक्स्ट डायग्राम. C2 का रोटेट कराएगा इसको, तो पीछे वाला तो एज इट इज रहेगा, H CS3. इसको 120 से यहाँ ले आए, तो ये वाला ये यहाँ आ गया, ये यहाँ चला जाएगा, ये यहाँ पर, ये वाला CH3 यहाँ आ गया, ये वाला H यहाँ आ गया, ये वाला H, राइट। दिस इज गॉस फॉर्म, दिस इज द करेक्ट आंसर। नेक्स्ट इज 2010 advanced question. In the Newman projection of 2,2-dimethyl-butane, तो पहले हम ड्रॉ कर लेते हैं स्ट्रक्चर। 2,2-dimethyl-butane, 1 2 3 4, 2 2 1 2, पहले यहाँ पर 2 पर 2 डाइमिथाइल है, CH2 हो जाएगा, ये CH3 हो जाएगा, ये H हो जाएगा। नंबरिंग कर देते हैं 1 2 3 4, तो X एंड Y रेस्पेक्टिवली B। ओके, तो देखिए X और Y क्या हो सकते हैं। तो इसमें हम क्या करते हैं, लेट अस फाइंड ये वाला कार्बन कौन है। 1 कार्बन 2 कार्बन 3 4 कार्बन है, ठीक है। ये पीछे वाला का, मैं इसको ऐसे स्ट्रक्चर को ड्रॉ करता हूँ। इससे जुड़ा हुआ है CH3 और Y, फ्रंट से जुड़ा हुआ है X H। देखो काउंटिंग कैसे कर सकते हैं, अगर इसको कार्बन 1 ले लिया जाए, इसको कार्बन 2, ठीक है, तो टोटल आपको 4 कार्बन लॉन्गेस्ट चेन में जानी है, 4 कार्बन अब जानी है लॉन्गेस्ट चेन में, ठीक है। 1 2, तो ये मैंने 1 ले लिया, 1 पर है H H और H, तो ये तो हमारा H बन गया। 2 पर है CH3 और CH3, तो यहाँ पर CH3 है, और 2 पर जो तीसरा चीज है वो ये है C2H5। तो एक हो गया X, तो हो गया H, और ये हो गया C2H5, ये आंसर हो गया, राइट। अब देखो दूसरा ये मोर देन 1 वाला था, तो दूसरा जो पॉसिबिलिटी है कि हमने रोटेशन जो ले लिया 1 और 2 के राउंड ले लिया। मैं दोबारा आपको बताता हूँ, 1 और 2, हम 2 और 3 के राउंड लेते हैं। मैं यहाँ पर 2 को लिखता हूँ और मैं यहाँ पर 3 को लिखता हूँ। 2 पर अटैच होगा CH3 और CH3, और 3 पर अटैच होगा H और CH3, ठीक है। अब देखिए, अब इस स्ट्रक्चर को मैं दोबारा आपको बना के दिखाता हूँ, या X का, राइट। मैं दोबारा बनाता हूँ, कंपेयर करो। अब मैं इसको क्या कर रहा हूँ, ये 2 और 3 के राउंड रोटेशन लेगा, ठीक है। इसको बना देता हूं मैं 2, इसको 3। 2 इसलिए बनाए क्योंकि यहाँ पर H और H है। 2 पर देखो क्या है, H और CH3 है, इट कुड बी CH3, और 3 पर CH3 है, CH3 तो ये भी CH3 होगा। इसका मतलब X could be CH3 also, Y could be CH3 also. If you think rotation about 2 and 3, D could be the answer. So in this case, we can have 2 answer, H, right? तो इतना ही क्वेश्चन था। अब आप अपने कमेंट को जरूर लिखिए, आप मुझे बताइए कि और कौन कौन से क्वेश्चंस का डाउट आपको चाहिए। फीडबैक दीजिए, क्योंकि मैंने अभी स्टार्ट करा है वीडियो बनाना। आई एक्सपेक्ट योर क्रिटिसिज्म आल्सो, feedback also, suggestion also, how to improve the video so that student community is benefited, right? तो अभी जो नीचे डिस्क्रिप्शन में बाकी डिटेल दिया हुआ है, जिसमें कि आप अगर व्हाट्सएप करना चाहें या मेल करना चाहें तो यू कैन मेल इट, राइट। तो आई विल वेट फॉर योर कमेंट। थैंक यू, बाय बाय, टेक केयर।